Okay. Okay, before we go to the next subchapter, any question regarding buoyancy? Ada soalan pasal buoyancy? Any confusing terms or whatever? Tak ada?
No, sir.
Tak ada. This we have done this yesterday, right?
Yeah.
Yes, dah buat So do you want me to repeat or we can go to next subchapter? Any thoughts?
Go to the next chapter, sir.
Okay. I think we have if you miss this, you can refer back to the video yes, for yesterday, so that you can refer there. Okay. Before that, as I mentioned in the group and in the classroom, you'll be having your online quiz kan? Is it online quiz you call it? Yeah, online quiz next week next. Let me try. This is next week, I think 23rd of November, which is hari Isnin. Okay, Isnin. Okay, so you have a few days to prepare, and the quiz will cover chapter 1 and chapter 2. So today we will be finishing all the subchapter in chapter 2, so you should be able to prepare lah for your online quiz, and you just finish your chapter 2, so I think it's still fresh in your mind, you still remember, so I hope you can do the quiz dengan baik lah alright. Okay, we go to the next subchapter. Okay, my pen now is working. Okay, so the next subchapter is stability, and why the buoyancy and stability is in the same subchapter, which is 2.5 kata silap, is the stability is related lah to buoyancy so that's why it's in the same subchapter, and you will be using some part of the buoyancy formula in the stability so that's why it's the same. And the meaning of stability, I think you already know, you just repeat it here. It's the ability of a body, whether it's submerged or floating, okay, to return to its original position after being rotated a small amount above the horizontal axis. So ni inilah daya apa? Stability, stable stable sorry. Okay, so there are two different scenarios. One in the whenever the body is submerged, okay, in the fluid, whatever fluid, and the second one is floating. Okay, let me go back to this. I want to allow people coming. Sorry. Okay, so there are two different condition. One, whenever the fluid, the object, the body is submerged, and two, the object or the body is floating. So two different scenarios lah. Okay, so the first one for submerged, it's very easy, it's very straightforward, tak pening, tak ada banyak sangat benda. Okay, you can tell the body or the object is stable if the center of gravity G, we call it CG. Okay, later on we call it CG. The center of gravity of CG is directly below the center of buoyancy. Okay, or we call it CB. Okay, if your CG is below your CB, okay, like in this case, this ball, the G is below your CB, that means this body or this object is stable. If your center of gravity of the object is equal with the center of buoyancy of the object, then the ball is neutrally stable. Okay, still stable, neutrally stable. Okay, and the last condition where your center of gravity is above your center of buoyancy, then at this point, in this condition, your object is unstable and it will rotate lah. Okay, whether it's rotate that side or this side. Okay, until it stop. Okay, the center of gravity is directly related to the weight and the weight of the object. Okay, so if the object, the weight is more on the bottom, like in this case the A, and the object the weight ni banyak tertumpu kat bawah kan. So that means your center of gravity is low, is very low. That means your object is stable lah kan. You know this. I mean previously we have learned before. I think in sekolah ke bila, tak bila. Kalau how you want to make your body stable, you lower your center of gravity kan. So that means you have a stable condition. Okay, but if the object, the weight is more at the top, okay, so that means your center of gravity is higher, and in this condition your body or your object is unstable. Okay, this is only the condition that you need to understand for any object submerged. Okay, you're only interested in the CG and the CB. So whether the CG is below your CB, that is stable, or if your CG is above your CB, then your body is unstable. Okay, so that's a first condition, first scenario in submerged. Submerged. Jangan lupa so it's submerged in the fluid. Okay, ini dah settle lah, maksudnya easily understood. Okay, and the second one, which is still easily understood, still easy, not too complicated, just that in this case, whenever the object or the body is floating, you have another term, another component where we call it as a metacenter, MC, and we will call it MC after this throughout the session. Okay, you still have your center of gravity, alright, and you still have your center of buoyancy, and the additional thing is you have your metacenter. So what is metacenter? It is an intersection of the center of gravity line, refer to the second picture, your center of gravity line with your center of buoyancy line. Okay, so this intersection here, we call it metacenter. So why you have this intersection, why you have this metacenter is, okay, look at this original position of the ship. This is stable lah, because your CG is above your CB, sama macam tadi lah for submerged. Okay, at this point is clear. There is no metacenter component. Whenever there is a wind, okay, coming from either this side lah, we take example at this side, a wind or a wave, arus ombak ke, push this ship, okay, and the ship will have some force lah, rotate to the right side, and the ship will be like this in the middle. Okay, so when it rotates, the center of gravity, okay, is still sama lah, ada, still there, but your center of buoyancy is shift, okay, shift towards the new position. If you see from here, because it have been rotated like that. Mula macam ni, lepas tu dah jadi macam ni. Okay, so you have your new position for your center of buoyancy. Okay, this intersection CG and CB, you call it metacenter. And because of you have this new center of buoyancy, your force of buoyancy will give a restoring moment. Akan ada force yang bertindak ni, akan force ni kan. So dia akan pusinglah balik ship ni untuk jadi stable, untuk return back to the original position. That means the body is still stable kan. That is the definition of stability kan. So the body will return back to its position after being rotated about a small amount kan, on horizontal axis This is horizontal axis. Okay, because the ship is rotated, so you have a new center of buoyancy, and the force of buoyancy will give restoring moment. Okay, so in condition B, the body is still stable because your MC is above your center of gravity. So what happen if the wind keep pushing the ship? Maksudnya angin tu lagi makin kuat, makin menolak kapal ni, and this ataupun the wave push the ship harder, and it will rotate the ship more lah kan, akan makin tenggelam if you can differentiate the picture between this height and this height. Okay, so your ship makin tenggelam, so your displacement volume underneath is changes kan. If you can refer to the picture for the first, so the shape under the fluid is like this. Whenever it rotated, the shape is changes. Dia berubah lah and if more, then the shape still berubah lagi lah. Okay, so these changes will affect your center of buoyancy. Okay, whenever it's pushed harder, okay, you will have your new center of buoyancy. Okay, kat sini, and this, like I said, the intersection of the center of buoyancy line and center of gravity line will have your metacenter. In this case, your metacenter is below the center of gravity, compared to this one. Okay, your metacenter is now below. In this case, it is unstable because there is a force. We will keep pushing this boat towards sini kan. Dia akan putar lagi, rotate this ship, and it's not unstable lah, because you have this buoyancy force about this position, the moment, and keep turning the boat lah, and it's unstable. So in this floating condition, what you have to understand is the body will be unstable if your metacenter is below your CG. Okay, your metacenter is below your CG kan. So if your metacenter is above your CG, then it is stable. Okay, itu je Okay, ada ni tak any question? Okay, so it's written here, a floating body is stable if its center of gravity CG is below your metacenter MC and above its center of buoyancy. Okay, so this so for floating body you have another term which is the metacenter lah. Okay, so how you want to locate where is your position of your center of gravity, center of buoyancy, we will look later. We will look after this. Okay, alright. Ni ada ke semua ni? Saya takut saya seorang pula.
Ada.
Ada ya?
Ada, sir.
Okay, alright. Okay, so we repeat again. Tadi ship kan, so ni ialah a cube or a box, any apa-apa lah So still this is a floating body, so it's floating in this fluid. Okay, this is your level of water. So this is stable because your center of gravity is higher than your center of buoyancy. So in this case, you don't have any metacenter kan, because it's apa? You don't have any external force that push your body or your object. So whenever there is a wind or wave or whatever, push your object, and then it will create a new position of your center of buoyancy kan. Okay, this your center of buoyancy, and this intersection, your center of buoyancy and your center of gravity will give you your metacenter. And if the metacenter is above your CG, then the body will restore back the position. Thus the body is stable. You will have a restoring moment because of this buoyancy force. Okay, it will rotate the box or the cube back to the normal position again, like this. And but if the wind or the ocean keep the wave keep pushing the box more, so the box keep rotating to the other side, and this will shift your center of buoyancy. Will shift to the left. Okay, and whenever it shifts to the left, and this intersection with your center of buoyancy and center of gravity, okay, this intersection will give your metacenter. And if your metacenter is below your CG, okay, metacenter is below your CG, then the body cannot come back to the original position, because it will keep the force, the buoyancy force will keep rotate the box and give the overturning moment and it will keep sentiasa berpusing sampailah habis, sampailah dia stop, whatever. So the body is not stable and it will not return back to its original position. Okay, so sama lah macam ship tadi kan. So ni ialah bongkar. So your center of gravity of a body is located at the centroid of the body, and the weight, and it acts downward through your CG, and the weight badan kita bertindak pada center of gravity. The center of buoyancy pula is located at the centroid of the displaced volume. Ni yang displaced yang merah ni. Okay. Ini. Okay. So your center of buoyancy is the centroid of this displaced volume. Ni. Just want to differentiate between the CB and CG. So your CB of body is located at the centroid of the displaced volume. So this force of buoyancy, it acts upward. So we have learned this in buoyancy kan. Saya nak masuk. Okay. Okay. So you can know your CB, your CB mana kat sini? Okay. Your CB is half of your displacement height lah, and your CG is the half of your total object. Okay. So that's how you locate your CB and your CG. So let's say this is HD, this level from level of water to your bottom. So this is the displacement height. Okay, half of HD is equivalent to your center of buoyancy, but for center of gravity is the total height lah, total height of the object. So half of this will give you your CG. Okay, it's very easy. Okay, this is if you want to just clear understanding on stable, neutrally stable and unstable. So this is stable because whenever you push the ball, and after a while it will come back to this position. But neutrally stable, when you push the ball still stable, but it moves to the other side, dia akan pergi sini and it stop there. And unstable, this lah, it can go up here or go down here, unstable. Okay. Okay, ni tadilah ni yang apa yang submerge for itulah yang submerge sangat senang, tak ada apa-apa any other component. It's just your center of gravity and your center of buoyancy. So if your center of gravity is larger than your center of buoyancy, then your body is stable. So don't worry, not to worry about object which is immersed. It's very easy. But for floating pun, I'm not too worried because it's very easy to understand. You have another metacenter component. Okay, so how we can calculate, or analyze whether the object is stable or unstable in any fluid with the floating bodies. Kalau the submerged tu tak banyak sangat, tak akan ada pun calculation submerged, because it's submerged. You will know from your CG and your CB. But floating, you need to calculate. You need to measure where is the CB, where is your CG, and find your metacenter. So that will tell you whether the body is stable or unstable. Okay, let's look at this procedure. Okay, I mean step by step, how you can know that the floating bodies is stable or not. Okay, first determine the position of the floating body using the principles of buoyancy. Okay, so this is you need to find whether the object is floating or not. Okay, whether it's immersed or not. Okay, and then locate the center of buoyancy, your CB. So like I said in the previous slide, your center of buoyancy is just the height, this displacement height divide by 2n. Okay, this height this displacement height yang tenggelam tu divide by 2, it will give you your center of buoyancy. Okay, and measure the distance lah from the bottom of the object. So this is your reference line. Okay, reference axis. So from this to your center of buoyancy, this is YCB. Okay, the distance between from the bottom to your center of buoyancy, then that is YCB. Okay, that's settled. And then you have to locate for your center of gravity. Okay, as I said before, your center of gravity is just half of your total object ni kan. Total object ni berapa tinggi dia, and this is your CG. Okay, that's why the CG is always higher than your CB at the beginning, because your total height lagi dah tinggi daripada total displacement height kan. Okay, and similarly from your reference axis, the bottom of the object, to your CG, it will give you your YCG lah. So Y ni jarak lah, distance dia. So YCG. Okay, now you know your CB and you know your CG. So you have your YCB and you have your YCG. Okay, that's settled. Okay, 1, 2, 3 settled. And number 4, you need to determine the shape of the area at the fluid surface. Okay, this is the fluid surface. Okay, so you need to determine the shape of the area and compute the smallest amount of inertia. Okay, I, Y, okay, for that shape. Okay, so normally we have whether it's a rectangle, or whether it's a triangle, or whether it's a cylinder. So you can find the second moment of inertia for this shape using this formula lah. For rectangle, so you have the length times base cube over 12, and for triangle, I'm not sure what is it. I think we have, okay, here we can go back, we can refer to here. For triangle, so you have the length times base cube over 36, and for circle or cylinder, okay, so your second moment of inertia is pi r to the power of 4 divided by 4. Right. So that's your number 4 step. You find your IYY. IYY of the shape. And then you need to compute the displaced volume VD. Volume yang kat bawah ni lah. The displaced volume ni. Berapa volume yang di displace ni? Yang tenggelam So you can find it by we know volume is area of the surface times the h, the height. So since this is a displaced volume, it means that the area times the displacement height lah, AHD Okay, let's say if your area of surface is rectangle, so this is the displacement height, yang tenggelam. Okay, let's say it's 2. Okay, so this is a cube bongkahan macam ni lah. Okay, so your displaced volume is the area of this rectangle, whatever lah, maybe 5 by 5 ke. So by 5 times 5 and times the displacement height yang tenggelam. Let's say in this case is 2. So 5 times 5 times 2. So that's your displaced volume. So depending on the shape lah, whether it's circle or triangle ke apa, so you need to determine the shape of the surface. So now you have your VD. Okay, why we need to find this IYY and VD? Because we want to compute this distance, BM. So what is BM? So BM is from your center of buoyancy, your CB ni, sampai ke your metacenter point. Ni dah lukis sini Ini BM. Okay, from your center of buoyancy sampai your the metacenter. So this is BM, and we can calculate it by using this formula IYY divided by displaced volume. Okay, you have find your IYY of the shape, and you can divide by your VD, and you will give you your PM, jarak from center of buoyancy to the metacenter. And then finally, the last step, you find your YMC. Okay, using this formula, YMC is equal to YCB, jarak yang ada bawah sampai your center of buoyancy, plus BM. And you will give your YMC lah. If you look from the picture, the diagram, YMC ni kat atas is equal to from bawah sampai CB, this YCB, plus from your CB to your M, which is the BM. Okay, so that's why YMC is equal to YCB plus BM. Okay, why this is important? Because you want this distance, this height, to compare with your YCG, your center of gravity ni kan, your HO divide the total height divide by 2 will give you your YCG. If your YMC is larger than your YCG, that means your metacenter is above your CG, your body is stable. But if your YMC is below your CG, that means your metacenter is below your center of gravity, that means your body is unstable. Okay, sebab tu you need to find YMC. And because it's shown here before, we have learned dalam ni, whenever MC is large than CG, then this is stable, and if your MC is lower than CG, then it's unstable. So that's why you need to find the value, the value of MC and CG lah. Okay, so that's the theory lah, the theory behind the stability. And we can conclude the condition for stability of bodies in a fluid can be summarized as follow. So one, for completely submerged body, saya cakap mula-mula tadi, is stable if the center of gravity, your CG, CG is below the center of buoyancy, below center of buoyancy. So this means your body is stable. But floating bodies, okay, it is stable if your center of gravity is below than your mental center. Okay, so this is different lah. Two different scenarios. One for submerged and one for floating. Okay, and much more we interested in floating bodies lah, because this is not straightforward to find. For submerged is very straightforward lah. You just determine the CG and CB. But floating bodies, you need to find your MC first. MC, then you can compare with your center of gravity, and it tells you whether the body is stable or not stable. Okay. So this another picture, maybe it's clearer than the one that I draw before. So again, to find your CB, okay, your CB, center of buoyancy, it is the HD by 2n. Okay, HD by 2. Okay, the displacement height from here, from your free level water sampai ke bawah. So this is your HD. Okay, so this HD divided by 2 will give you your center of buoyancy, and your center of gravity is just half of your total height object lah. Okay, the total height of object HO divided by 2 will give you your YCG kan, dari bawah ni, dari bawah. Okay, reference dari bawah. So this is dari sini your YCB, and dari sini sampai your point center of gravity, this is your YCG. Okay, okay. To find this, the condition is there is no load on the object. Tak ada load pun kat sini kan. If you can see the load, this cube is floating, and there is no additional load yang diletakkan atas ni. So might be is different cases where there is a load on the object, and then there is some changes lah how you can find your HD kan. Okay. Okay. So this is apa tadi? Jadi YCG, your center of gravity is the total object, the height of total object just divided by 2, and your center of buoyancy, the displacement height HD divided by 2, and you need to remember this formula to find YMC, the mental center, is equal to BM plus YCB, and your BM you can find it through this formula. It's the second moment of inertia of y axis, okay, divided by the volume, the displacement volume, displaced volume, okay, and you know the displaced volume is the area of surface times the displacement height will give you your VD, and your second moment of inertia is just referring back to what shape lah, to what shape of this of the area, whether it's rectangle or triangle or circle. So you find your BM and you find your CB, then it will give you your YMC, okay, and whether the body, the YMC is larger than YCB or lower, that will tell you whether it's stable or not stable, or naturally stable, sama. Okay, so that's it lah for the theory behind. Any question? That's all right?
Tak ada sir.
Tak ada So kalau tertanya, kalau tak faham, just tanya je. Don't be shy, don't be scared. Okay. There's no stupid question. You just want to understand anything. Okay, now we look few example. I think there's 1, 2, and 3. 3 example 3 example on how you on this topic lah, on stability. Okay. Example 1. So this is without external load. If you can see from the picture, there is no load on the object. So this is without external load. Okay, it says here, a solid cylindrical rubber spar buoy is floating in sea water. Okay, they give you sea water. As shown in the figure, the specific gravity Sg of the rubber spar buoy and the sea water are 0.95 and 1.03. So this for a specific gravity for sea water is 1.03. The diameter of the spar buoy is 0.5 meter. So this is the diameter of the spar buoy is 0.5 meter. Alright. So determine the depth D of the spar buoy immersed in sea water. So what they ask you to find is the displacement height kan? HD sini ni. Okay. So they want you to find the HD, but they give you the HO, the height of the object is 5, and they want you to find HD lah. Okay, this displacement height. So how we can do this? This is concept of buoyancy kan? Yesterday we have learned this buoyancy, because it's floating. Okay, you have two component of force. You have weight, the weight of the body going down, and your buoyant force FB going up. Okay, ni soalan dah buat soalan kan? Dah buat soalan yang pasal buoyancy ni. Because the object is floating, okay, and they want you to find the HD, and we know the summation of vertical force is 0, okay, and you take upward is positive, so that means FB minus W is equal to 0, and FB is equal to W. Okay, and then you can change this in term of rho GV kan. So FB rho bawah ni yang buoyant force ni, you know buoyant force FB is equal to the rho of the fluid and times G and times V and V. Okay, the V displacement V lah VD apa yang ni kan, yang dalam meja bawah. Okay, and this is equal to W, and your W is the rho of the object, okay, times G times the volume of the object. Okay, faham kan? Sampai sini boleh kan? Any question sampai sini?
Boleh sir.
Boleh boleh follow Okay, so you know your VD, VD ni kita boleh tulis dalam AHD kan? Okay, so you can write it the rho of the fluid times G times area of the surface, which is this circle lah. So this sama kan, shape ni sama je pada cylinder. So times HD, the one that you want to find, is equal to the rho of the object G times A at the surface times the total height kan. Because for volume of the object, we need to times the total object lah. Okay, so we have this equation, and we can cancel out the G because it's the same, the A also the same, so we can cancel out. So it will leave left to us is rho F, rho of the fluid times HD is equal to rho of the object times H of the object. So they ask you to find the depth D kan, the HD lah. Okay, the height, the displacement height. So this is equal to rho of the object times the total height divided by the rho of the fluid. What's the answer? The HD. So the rho of the object is they give you the SG is 0.95, so that means it's 950, and you just times 100,000, and the H of the object is 5. Okay, and the rho of the fluid is they give you the SG, so it means 1030. So So if you calculate this, it will give you 9550 times 5 divided by 1030. It will give you
Dapat 4.6.
4.6 4.61 So your HD is
Ya.
4.61 meter here kat sini 4.61. Okay. And the next question, they ask you to find the stability of spar buoy from the metacentric height. Okay, after that they ask you whether this buoy and this spar buoy, rubber spar buoy, whether it is stable or not stable. That's why they ask you to find the HD, and because you will using this to find your Y apa for HD. Y apa?
YCB.
YBC.
YCB
YCB.
or YBC or whatever lah, YCB kan. That's why in the first question they ask you to find this, because you will use this number, this value to find your YCB kan. Okay, let's see how we can analyze whether this object is stable or not stable. Okay, now you have your total height of the object. Dah masuk je sebentar. Okay. Okay, so now you want to analyze whether this object is stable or not stable. First, from your step and from the procedure yang kita tengok kat lecture slide itu, the first you need to find your CG kan, your YCG, correct? So how we find YCG? Anyone?
HD divided
H apa?
HD divided by 2.
YCG, center of
HO.
gravity.
Oh, HD kan.
HO divided by 2 kan. So this is 5, because they give you 5 divided by 2. And this is 2.5 lah. Okay. So that's one YCG. Cuba tengok sini pula Sambung kat sini pula Dia tak ada ruang kat situ. Okay. And then you need to find your YCB kan. Okay, YCB equal to apa tadi? YCB?
HD bagi dua.
Okay, HD
Over 2.
over 2. So this is the one that you have calculated, 4.61 divided by 2, and they will give you 2.3 apa? 2.305 kan?
2.305.
So 5. Okay. Okay, that's your YCB. Sorry tak nampak kan ni. Okay, if you draw in your apa kat sini ni, maksudnya YCG somewhere 2.5 sini, your apa YCG G, and your B is below lah, below sikit. 2 ni sini B 2.305. Okay, next what you have to do, find what? Apa next?
M.
BM.
BM kan? So you need to find BM. Okay, BM equal to apa formula dia?
Pi R.
Apa? Pi R.
Pi,
Yang circle moment of inertia tu kan?
Pi R 4.
Over. No, the formula first before we go.
I by Y.
Divide by VD kan? Okay. Okay, now what is the circle moment of inertia for this shape? Tadi pi apa?
Pi R 4 over 4.
4 over 4. And because it's a circle, and so you need to use this formula. And this is the R is 0.25 kan?
0.25.
0.25 kosong 4 darab pi bahagi 4. That's your IYY. You need your VD. What is VD? V bawah ni, the displacement V. Apa? VD. VD equal to the area times the HD kan? Betul? Betul tak?
Betul.
So what's the area of the circle? Kan circle kan? Apa formula area circle?
2 pi r.
2 pi r. The
Pi r
area.
square.
Pi r square. Don't forget. It's pi r square. Okay. Times your HD lah. HD dah lupa dia kan. 4.61.
61.
Okay. Then this will give you your displaced volume. Okay. And then you got this value, and your IYY divide by V will give you your BM. So what, tell me what your BM number? Apa value BM? Last sekali. BM equal to apa dapat? Kalau orang kira ni, saya tak kira, saya tunggu awak. Berapa? BM? Dapat lah? Berapa nilai BM?
Saya dapat
3
3.37
point
darab 10 kosong negatif
3.37 darab
10 kosong negatif
10 kosong negatif 3. What's the unit? Apa unit dia? V meter 03 kan. Your IYY ni meter 04 kan. Kalau you have pi r square, pi r power of 4 kan. Betul. So it left to you with only 1 meter lah sini kan. BM ni kan jarak je kan, jarak panjang kan, BM. Berapa jarak dia kan. So in meter lah. So don't forget your unit. Okay, so that you not mess up lah with your calculation So your IYY is meter to the power of 4, your volume is meter cube. So that means when you divide, it left you with meter lah. So your BM is 3.37 times 10 to the power of minus 3 meter. Semua dapat yang sama ke? Takut nak check je. Sama tak? Yang lain? Siapa lagi yang kira tu? Sama okay. So that's your BM. So next, apa lagi yang kita perlu buat?
cari YMC.
Okay, how you find your YMC?
BM plus YCB.
BM plus
YCB.
YCB. Okay. Now tell me what's the number for YMC. BM you already have here, plus YCB. Mana YCB? YCG. Here sini. Okay. How much? What's the value for YMC? (2.305 plus 3.37 to the power of minus 3). So 2.3 juga lah. 2.3 siapa? 2.3 berapa nilai?
2.31.
2.31. Okay. Meter kan? Okay. So now how you can conclude whether the body is stable or not stable?
Kalau YMC tu lagi tinggi daripada YCB, dia stable.
Compare dengan YCB.
Ah.
Remember? We
YCG.
compare with YCG.
Oh, YCG.
Don't forget Okay. So now your YMC dengan YCG. Okay. So your YMC is 2.31 and your YCG is your YCG is 2.5 Sini kan 2.5 kan. And this is less, your YMC is less than your YCG. That means your body is
Unstable.
unstable. And so you can conclude the body is unstable. Okay. Itulah dia. Okay. How normally the question asks you to analyze whether the object is stable or not stable, and you need to find all this value lah. Okay. Okay, that's one example. Any question before we go to next example?
No, sir.
Tak ada Okay, so next example. So this is with external load. Maksudnya dekat atas objek tu ada load. Okay, so this is without external load and this is with external load with external load. Okay, so there ada load lah atas ni apa-apa lah Then in this case is sand. Okay, a sand boat. Okay, there's a boat and there ada sand atas. So a sand boat is used to transfer sand from a quarry to a factory along the river stream. The mass of the sand loaded into the boat is 50 ton. Okay, tell me what is the conversion to 1 ton to kilogram? Is equal to
1000 kilo kot sir.
Yes, correct. 1000 kilo Remember you need to use all the value in the standard unit. So this boat has 50 ton. Okay, that means is 50,000 kilogram. Okay. Determine the stability condition of the sand boat by calculating YMC. Okay. Sama macam tadi, cuma dalam ni dia ada external load. Okay, what you need to find first? Oh, no, sorry. Sorry. Sebentar. Okay. Go back. Okay. Now, this are two picture from the mass, and they give you the mass the M is equal to 50,000. So you already can find what from the mass? Apa boleh jadi?
W.
Okay, what is the W? Equal to
mg.
Okay, you just times the 50 times the G 9.1, and this give you berapa nilai dia? 50,000 times 9.81
490,500.
490,500. What's the unit?
Newton.
Good. Okay, this is kat sini maksudnya dia ada weight ke bawah. Okay, and you know this is the weight 490,500, and you have your buoyancy force okay, and because it's floating, okay, so your FB is equal to W lah, kan? Betul? Okay, now from your FB, the buoyant force formula, which is kat sini, the rho, okay, the rho of the fluid times G times the displacement volume OGV, is equal to 495,000 500. Okay. Right? Because you need to find your ni kan apa displacement height ni. Okay, because they give you your center of gravity. The center of gravity dah bagi dah 1.5. But you don't have your center of buoyancy. Because you don't know what is the displacement height. Okay, that's why you find your displacement height using this formula. Because it's floating, so W is equal to FB. Okay, you have your you can change your VD to AD kan, the area times the HD. Okay, the rho of the fluid times G times area times HD. Okay, is equal to 490,500. Okay, you know your rho of the fluid. Okay, they give you somewhere here. Okay, the density of freshwater liquid is 1000, and you know your G 9.81, and you know your area of this surface is 2 times 10. Okay, and this side view kan, so 2 times 10, sama and times HD equal to 490,800. So what is the HD? HD equal to berapa nilai dia? Apa? HD 490,000 divide 1000 times 9.81 times A 20. Berapa dapat? Berapa?
2.5 sir.
2.5 meter. So this is your HD sini kan. So from HD you will know your what? From HD
YCB.
YCB. Yes, correct. So what your YCB is HD over 2 kan. You know your CB lah 2.5 divided by 2. Okay, so your YCB is 2.5 divided by 2 is equal to 1.25. Okay, so you have your YCB, you have your YCG. Okay, now they said kita nak ni kan, cari sama ada dia stable atau tak stable kan. So you already have you have done your second and third step kan. Ya ke? Sama dia dah cari YCG, dah cari YCB. Next one you need to find what? Your
BM.
Correct, good. Which is equal to
IYY over HD over VD.
Y over VD. Okay, so tell me what is the IYY for this case?
The rectangle, so LB square LB power of 3
cube divided by
plus
11.
Plus.
Okay, the length is 10.
10.
The B is 2
2.
divided by 12. So equal to 80 bagi 12. Apa?
6.67.
6.67 meter. So that's your BM. No, that's your IYY kan? Sorry. So you need to divide by
Tak,
VD.
saya dah divide dengan 12.
Dah divide dah?
Dah.
Okay, sorry. Sebab ni tu dia kat sini bagi 12 ni kan. So you have divide by ni IYY lah kan?
Tak, saya dah dapat BM terus. Saya terus divide dengan 12.
Tak, divide by VD itu jadi BM.
VD tu.
Faham tak?
Oh, okay.
So
Salah,
ni
salah.
LB3 ni
IYY.
bagi 12 bagi VD.
So IYY je lah.
Ni IYY lah 6.67.
6.67.
Okay, bagi VD berapa?
VD
VD equal to
area surface dengan HD.
Okay, and this is
HD area dia tadi
Area apa?
Area 20.
20. Okay, good.
HD tadi berapa?
D berapa? Berapa
2.5.
2.5. Okay, then how much your VD? 50 lah kan? 50 Betul? So
Betul.
A 20 darab 2.5 Okay. Now what's your BM then?
0.13
0.3 meter. Okay. So what's next?
cari YMC.
OMC. How?
BM plus YCB.
BM plus
YCB.
YCB. Okay. BM, your BM is 0.13. Good. Plus YCB berapa? Mana YCB? Where's YCB? YCB. Only 1.25.
1.25.
1.25 1.25, and this is equal to 1.38 kan? 1.38 meter. Okay, finally what you do? Apa dah sekali?
Compare
Compare apa dengan apa?
YMC dengan YCB.
YCG. Okay, now your YMC is 1.38 and your YCG is, mana YCG? Oh ni 1.5. Okay, and this is less. Okay, and that means it is
Unstable.
unstable. Kan? Boleh faham?
Boleh sir. Boleh sir.
Any questions or any apa-apalah, any tak faham ke kat mana tak dapat? Berapa sekarang? Buat 110. Okay. Any question? Semalam terlalu banyak tanya sampai habis masa.
Ada sir.
Kan? Ini tak ada tanya lah. Kejap lah masa. Okay. So that's it lah how you do this problem regarding the stability kan. Okay, you need to follow step by step. Find your YCB, find your YCG, and find your BM, and then find your YMC, and last one you compare with your YCG. Do you think it's difficult to do?
Biasa-biasa je.
Biasa-biasa. So I take that as easy lah Okay, because this not I think it's quite straightforward lah in this topic, buoyancy and stability. Okay. Ada satu lagi. Last example. Okay, how we can do this? We buat ada masa banyak lagi ni. Okay, so this is with or without load. Sorry. Alamak, apa ni? Ada load kan? Okay, you have your load which is 150 kilonewton. It's already give you in W lah. Okay, tadi yang second example they give you in mass kan. You need to convert first. Okay, now they ask you note the location of the center of gravity. Dia dah bagi dah CG kat sini kan, dalam gambar ni. So this is front view. Okay, sama macam front view ni lah yang ni kan. Okay, so they give you the center of gravity is equal to 0.8. Determine whether the boat is stable in fresh water. Okay, Okay, macam mana? What is the first step?
FBD tu.
Okay, FBD for this diagram. Alright, so you have your W going down, and you have your buoyant force going up. Okay, that's good. So your FB equal to W. Okay, and then
FB row apa ni? Row GV equals to
rho GV equal to W. Okay, what is the rho? Rho for what?
row for water. Apa ni?
Okay.
Ni air.
Ni,
Ah.
fresh water.
Fluid.
Kan? The fluid dia fresh water lah. Okay, I just say here, the rho of the fluid times G times V. V apa? V kat sini, V apa?
B
Ha?
GV fluid.
Ya, apa? VD kan, displaced volume. Ni kan kat sini, volume yang tenggelam. Okay, remember to put the apa denoted so that you're not confused. Okay, the volume apa displaced volume equal to W, so you already know your W kan. This is equal to 150 Newton. Convert to unit. Okay, so your rho of water is 1000 times 9.81. Okay, what we need to do with this VD?
Kita separate.
Okay,
AHD.
AHD, good. This is equal to 150,000. Okay, the area of this is apa area untuk problem ni?
6 darab. Apa ni?
Nampak tak? The base is 2.4.
2.4. 6 darab 2.4.
Okay, 2.4 times 6. Okay, times HD equal to 150,000. Okay, now you can find your HD lah What's your value of your HD? Berapa HD dia?
1.06.
1.006 meter. Okay, good. Okay, after that, what you need to do?
Cari apa ni? YCB.
Okay, YCB equal to
HD over 2.
HD over 2, good. So this is equal to
0.53.
0.53. Okay, so you have your YCB. What else you need? Huh?
PM
Yes, BM
BS.
equal to
M equals to IYY over VD.
VD, good. So what is
Okay.
your IYY?
IYY rectangle, so LB
LB
cube over
over
12.
12. And this is equal to 6 times 2.4 cube over 12. This is
6.91.
0.91. Apa unit dia?
Meter.
Hah?
Meter cube.
Belum
No.
cik, DVD.
Meter? Meter apa? Apa unit dia? Meter? Ni L ni meter. B ni meter juga kan? Meter kuasa apa?
4.
4 kan? Remember you can use times kan? 1L 1 meter. B ni 3 kali meter. So 4 lah. Okay, your VD?
VD AHD.
AHD, good.
So
The A Apa A dia? Hello?
A dia
A dia?
2.4 darab 6.
Berapa dah 6? Okay, good.
So darab 1.06.
1.06. Yes. And this is
Dapat 15.26.
11.26. Unit
M3.
M3. M3 cube kan? Okay, good. So you know your BM lah. Okay, what's your BM then? Berapa? 6.91
0.45 meter.
0. Berapa?
45
45
meter.
meter. Good. Okay, next. What else?
Kita compare. YMC.
YMC. You need to find YMC.
C BM plus YC.
BM plus Y. Whatever?
YCB.
YCB. Okay. So this is BM is berapa BM? 0.45 plus the YCB is
0.53.
0.53, and this is equal to
0.98.
0.98 meter. Okay, next, last one, finally,
Kita compare YMC dengan YCG.
YCG, good. So YMC is equal to 0.98 and your YCG
0.8.
0.8. So this is larger
YMC higher than YCG, so stable.
stable. Okay. Dah, itu je lah. I think it's very easy. That's why I say I'm not too worried of this topic. Easily understood by you, I think, hopefully. And I think you just need to do more questions and do questions, and then you will get it lah, how you can find how you can solve this problem in this topic. Okay, any question yang lain?
Tak ada sir.
Tak ada yang lain? Tak ada? Siapa yang lain?
Tak ada sir.
Tak ada So
Sir.
yes.
Kalau yang untuk soalan stability ni kan, ada kita punya returning moment dengan overturn moment kan. Ada ke soalan dia suruh kira moment? Tak ada.
Not
Itu
that
just theory je.
yes, not that I'm aware of. Itu teori lah, how the stability of body will turn back end. So there is I'm not aware. There's no yang saya tahu tak adalah soalan. But I will double check. Okay, let me double check first. I don't want to give a fake news. Okay, let me confirm this, and I will post it in the group lah. Okay.
Alright, okay sir. Thank you sir.
Alright. Any other question? Okay, what you need to aware only because normally on the floating body je lah yang dia nak analyse kan. For submerged is easily ada tak payah susah, tak ada apa-apa pun. It's just a matter of whether your center of gravity is larger than center of buoyancy. And for it's immersed, okay, there's no metacenter component. Okay. Ada lagi soalan?
Tak ada sir.
Tak ada? Yang lain-lain? Tak ada? Okay, I think that's all. We can finish earlier because yesterday we finished late. I will try to find more questions. Okay, I will try to ask from other lecturer whether they have a more set of tutorials for you to do, and so that you can prepare lah for your online quiz kan. This bila Tuesday 23rd 23rd November, Tuesday dia Tuesday. 23rd November. Oh, Monday, sorry. Monday. Senin depan. You have few more days lah. Jumaat, Sabtu, Ahad, Isnin. Jumaat tu. 3 more days before your quiz. Okay. So hopefully you can revise back chapter 1. Chapter 1 you learn with Madam Aina kan. When saya masuk dah chapter 2 kan, dah separuh chapter 2. Separuh ke chapter 2? I'm not sure. But chapter 2 lah. So you need to revise back chapter 1 and chapter 2, and the quiz will be at night, 8:30, okay, to 9:30, through U-Future, okay. So you need to log into your U-Future lah, okay, to do the test, to do the quiz, okay. Itu je lah, okay. Just prepare for your quiz. Okay, I think that's all for today. Please don't forget to fill up your attendance form. Let me stop record first.